Okay, now we're going to look at another method to divide that's called synthetic division, and you're going to like it better. It's a little bit easier, but in doing synthetic division is something that you're going to need to get accustomed to because we're going to do it a lot over the next few sections. Now, setting a problem up for synthetic division is different than setting it up for long division. With your divisor, what you got to do is do the opposite of your constant. So my constant here is positive 2. I need the opposite, which is negative 2. Okay, and we're going to put it like in a, kind of box it off here in a corner. Now, you're going to put a list of numbers across here that's going to come from what's called your dividend, and you're just going to pull the coefficients. So my coefficient here is 2. The coefficient here is negative 1. This one's coefficient is positive 2. And then I've got my constant, which is negative 3. So pull just your coefficients of each term and your constant. Now just leave you like one line of notebook paper right here to be able to come in and put some numbers. Okay, I drew the arrow because your first step is you're going to bring this 2 straight down. Now you start by multiplying the negative 2 times the positive 2, and that's going to give you negative 4, and you're going to put it here. So negative 2 times the positive 2 is negative 4. Now these two numbers you're going to add. So you're going to add those two numbers. So negative 1 plus negative 4 is going to give you negative 5. Okay, so now we do the same thing. So negative 2 times the negative 5 is going to give me a positive 10. And now I add those numbers. So if I add 2 and 10, I get 12. Okay, so now I multiply negative 2 times the 12, which is negative 24. And now I add these numbers, which is going to give me negative 27. Now I just always take and box off that last number because the last number that I have here actually represents my remainder. Now, writing out your answer has to be written out where it looks exactly the same as the problems did a while ago. You've got to put your x's back in it. So here's how this is going to work. You're going to use these numbers as your coefficients and your constants. But you always start out with one less power than what the problem is. So the power of this dividend was a third power. So I know that my answer is going to be a second power. Like I know the first term is just going to be an x to the second, okay? The first number you have here is going to be the coefficient. So this 2 goes here. But I know to start this one out as the exponent as a 2 because it's one less than the problem. Okay, so what's going to come after your second power will be an x that's just to the first power. And this number is going to be its coefficient. So you just say minus 5x. And then what comes after x to the first power is just a constant. And that's going to be the positive 12. Now you do the same thing that we did with the remainder a while ago. Put a plus sign. Take your remainder, which remember I said this last number always represents your remainder, and you divide that by the divisor, which in this case is the x plus 2. So this is your final answer. Okay, let's look at another one of these. Okay, setting this one up, go to your divisor. The constant that I have here is negative 3. I need the opposite of the negative 3, which is positive 3. Okay, so the first coefficient that I have here is just the understood positive 1. Okay, what I have next is negative 2. Now, what I'm supposed to have after x to the third power is an x to the second power, and since I don't have x to the second power, I have to fill in with a 0. So you have to fill in with zeros here just like you had to do when I explained that with long division. So this is my fourth power, third power, second power. So what's next is my first power, which I do have of x to the first power. Its coefficient here is an understood 1. Now what's supposed to come after an x to the first power is supposed to be just a constant, just a number, and I don't have it, therefore it's understood to be a 0, okay? So don't forget to fill in zeros on these. Okay, remember, first number comes straight down. So you start by multiplying these two. So 3 times 1 is going to give you 3. Okay, so now you're going to add these. So if you add those two numbers, you get positive 1. Okay, so now I multiply 3 times 1, which will give me 3. And now I add these. Of course, 0 plus 3 is 3. Now I multiply 3 times 3, which will give me 9. I add the 1 and the 9, so I get 10. And now 3 times 10 is going to give me 30. Of course, 0 plus 30 is going to give me 30. So remember, that last number is always going to represent my remainder. Okay, so when I come back to write out my answer here, okay, so I know that my first term is going to have to be an x to the third power. Remember, it always has to be 1 less than what you have in the problem. So I know it's going to be an x to the third. This tells me that the coefficient is just going to be a 1. So then this would have to be a 1x squared. You know, just go in descending order. And then I would have a plus 3x to the first power. And then what comes after that, remember, is just your constant. And then you would have plus your remainder over your divisor. Of course, all these ones, both of these that I've written, this one that I've written, would be understood. You know, you wouldn't have to write those if you didn't want to. Okay, so that's how you do synthetic division. So what I'm going to do next is show you something that you can learn or that you can figure out by doing synthetic division. So first of all, let's talk about what's called a factor theorem. Okay, x minus a. So like if you were to take something and factor it, of course factoring is something that we've already done a few times. But you know, when you factor things, you know, typically you've got all these sets of parentheses. So you have x minus a is a factor of some polynomial only if the x minus a divides the polynomial evenly. Now, when something divides something else evenly, remember that just means that you have a remainder of 0, okay? Now, just kind of relating this back to numbers for just a minute, like if I said, okay, what are my factors, and this is not something you have to write down, but if I say, okay, what's my factors of 6? Well, that would be 1, 2, 3, and 6. And that's because all of these numbers will go into the 6 evenly. It'll divide 6 evenly with a remainder of 0, okay? But instead of wanting to know if just a number is a factor, we want to know if a binomial is a factor, okay? So here's the example of this. Okay. So determine whether each binomial is a factor of x cubed plus x squared minus 16x minus 16. So this is my polynomial, and I want to know, is this polynomial, or is x minus 4 a factor of this polynomial, okay? And we can do that or figure this out by doing synthetic division, okay? So remember, I want to do the opposite of this number. So that's going to be a positive 4 when I set up my synthetic division. And then I would have 1, 1, negative 16, and negative 16. Of course, that's coming from here, 1, 1, negative 16, negative 16. Okay, so let's go through our synthetic division. Okay, bring the 1 straight down. So 4 times 1 is 4. Add, you get 5. 4 times 5 is 20. Add, you get 4. 4 times 4 is 16. Add, you get 0. So, based on what the factor theorem says, is that x minus a, in this case that's x minus 4, so x minus 4 is a factor if it divides evenly, which means a remainder of 0. And that's exactly what I have here. I do have a remainder of 0, so you can say that x minus 4 is a factor. So that would be a yes to the question, okay, or determine. But it's all because the remainder is 0. Okay, let's check this one. Okay, so this time we want to know if x plus 2 is a factor. Now, this is going to have 3 factors. Of course, we've already talked about the fact that your exponent will tell you how many answers. It also tells you how many factors. So it has 3 factors. Okay, I need the opposite of my constant here, so that's going to be a negative 2. And I'm going to have the 1, 1, negative 16, and negative 16 again. Okay, bring down your 1. Negative 2 times 1 is negative 2. Add, you get negative 1. Negative 2 times negative 1 is positive 2. Add, you get negative 14. Negative 2 times negative 14 is a positive 28. And if you add here, you're going to get 14. So in this case, it would be no, x plus 2 is not a factor. And again, that's because it didn't divide it evenly, okay? Remember, you have to divide evenly in order for something to be a factor, which means to divide evenly, you have to have a remainder of 0.